Here's a little bit to solve equations. So one thing I want you to keep in mind is the difference between solving an equation and simplifying an expression. So if we were going to simplify x over 2 plus 1 over 3, what would we do? We'd get a common denominator, right? So I would have to multiply x over 2 by what? 3 over 3, right? So I didn't multiply by the number 3 there, right? I multiplied by the number 1 in the form of 3 over 3. And then multiply 1/3 by 2 over 2. So we get 3x plus 2 over 6. Yeah? Okay, if I want to solve x plus 2 equals 1/3, how do we solve equations containing fractions?
Don't you have to multiply by 6 over 6?
So let's see what happens. If I multiply by 6 over 6, this becomes a 3, and then that becomes a 2. So here, let me do it a different way. So if we factor, we'd have 2 times 3 times x over 2 times 3 times 2. Which would give me x over 2 equals 1 over 3. Did that achieve what we were going for when we multiplied? Because, like, didn't we just get the same thing we started with? So is 6 over 6 really what I want to multiply by? What do I want to multiply by? Okay, so we could... Why do you want to multiply by 2 over 1? Okay, so to clear denominators? So what would I multiply by to clear all my denominators? Well, if I multiplied by 3, that would cancel the one on the right. Would it cancel the one on the left?
Can't use 6, so...
Why can't I use 6?
You just said you couldn't use
Well, that's...
6.
I did not do 6. I did 1.
6 over
6.
Yes. 6 over 6 is not the number 6. It's the number 1. The number 6 is 6 over 1. See, y'all roll your eyes at me when I correct you when you say 3 over here and I say you mean 3 over 3, because then we get over here and we think we're doing the same thing when we say 3, but we're not, right? 6 is 6 over 1. 6 over 6 is the number 1. They're different. How come I can do this here, but I couldn't do 6 over 1 here? Yeah, because there's an equal sign, right? So this comes back to, well, here, let's finish this. This becomes 3x equals 2, so x equals 2/3. So this comes back to that whole difference between, the different types of scales, right? So, over here, this expression has a set value. So it's like if I step on my bathroom scale. So I can rearrange, this sounds really bad, but I could rearrange my body parts. I could cut off an arm and put it over here and like do whatever I want, but I would still weigh the same amount, right? The quantity that scale reads is the same no matter how I move, right? It has a set value. But if I put 6 of myself on the scale, would it have the same value? No, it would be 6 times bigger, right? We can't just make something 6 times bigger because then it's not the same. Over here, all we care about is, so it's one of these scales where neither side tells us the value or the weight. All it tells us is if they're equal. So if I make one side 6 times bigger and I make the other side 6 times bigger, I haven't upset that equality, right? The balance is still there. But we can't, like, I mean, do you guys think that x over 2 plus 1/3 it could possibly be equal to 3x plus 2? I mean, we could make it even more obvious if we want, like if I was doing 1/2 plus 1/3, and you multiply by 6 over 1, you get 3 plus 2, which is 5. And I think we can all agree that 1/2 plus 1/3 is definitely not 5, right? Like if I have a third of a pizza and you have a half of a pizza, we do not all of a sudden have 5 pizzas, right? So, and the reason this doesn't work is because it simply makes it way bigger, right? We're just making that expression 6 times as big. When we have an expression, we're not allowed to do that. The only thing we can do when simplifying an expression is multiply by 1. So multiplying by 1 doesn't change the value.
How is x equals 2/3 the solution for x over 2 equals 1/3? Because if you substitute the 2/3 where the x is, that doesn't even make any sense.
Well, we learned how to simplify complex expression or complex fractions, right? So 2/3 divided by 2 over 1 is 2/3 times 1/2. And those 2's cancel and we get 1/3 equals 1/3. Sometimes, I will say, like when we do rational equations like this with a bunch of fractions in them, sometimes checking your answer can cause more errors than, like because you check your answer wrong, you think you made a mistake solving, and people make less mistakes solving than they do checking their answers when they try to plug things back into like the big complex rational equations, which isn't me saying like checking your answers is bad. You just want to be careful because sometimes the calculations get a bit messy and can cause more harm than good. So when we are simplifying an expression, the only things you're actually allowed to do when you simplify an expression are, so you can do operations that are already there, but the only new operations you can do are multiplying by 1 and adding 0. And there's lots of creative ways we can do those two things, but those are the only two things that don't change the value of the expression. Here, multiplying by 6 changes the value. Of the right side. If only the right side existed, that would not be okay. But that's okay because we have a left side to balance it out. watermark.
You can't have can you have something that doesn't have a left side?
On the left. Sure, this doesn't have a left side. Right. And that's the key to the whole thing, is if there is an equal sign, we can do any operation we want, right? Over here I said the only operations we're actually allowed to do are multiplying by 1 and adding 0. Over here we can do anything we want. Like I can divide both sides by 10 billion if I wanted to. Like it wouldn't get me any closer to the solution, but it wouldn't violate the equality, right? As long as I keep it balanced. So this is really important because it's very easy to get adding and subtracting fractions, like we did here, mixed up with solving equations that contain fractions. So it's really easy to try to clear fractions when you can't clear fractions, or it's less common for people to do it the other way around. But you want to just be really firm in that idea that when there is no equal sign, we cannot multiply by anything except for 1. So anything we multiply by has to be the same on the top and the bottom. Okay, so let's solve some equations. Do this one. X squared over x minus 1 equals 1 over x minus 1. So just like we've been doing, if there's addition or subtraction, we're going to put that in parentheses. Well, I'm going to wait a minute. So if we go along with the same theme that we've been using to solve equations containing fractions, how would I clear fractions here?
So you can have to figure the common denominator still, right?
Well, yeah, we have to figure out what the LCM is. We don't have to get common denominators, but we have to figure out what the LCM is. In this case, what's the LCM?
X minus 1.
Just x minus 1, because they're the same. And so I'm going to multiply both sides by x minus 1 over 1, because that will allow me to cancel that x minus 1. So I'm going to do x minus 1 over 1 times the left side. And then x minus 1 over 1 times the right side. And again, we're allowed to do that because we did it on both sides of an equation. So this cancels my denominators. What do I end up with?
X2
X squared
over 1,
over 1?
which is the same as x squared.
Okay. Is that all I get?
So
Equals 1.
Equals 1, yep.
oh,
So this is a quadratic equation because it has an exponent. So what's the first thing we need to solve a quadratic equation?
Is this where we're like equaling it to 0?
Yeah, we got to get 0 on one side. So we'll subtract 1 from both sides. And then factor. So x plus 1 times x minus 1 equals 0. And then we set each factor equal to 0. And we get x equals negative 1 and x equals 1. I want you guys to check both of those solutions, so you check them separately, one at a time, in the original equation and tell me what happens. So to check, we just plug the solution into the original equation. What'd you guys figure out?
It works.
Which does?
The negative one.
Right, so on the left, or for -1, we get 1 over what?
Negative 2.
-2 equals 1 over -2. That works. What about 1?
1 over 0.
Which is what?
Zero. One.
Undefined.
Undefined.
It's undefined. What that tells me is that 1 is not a solution. So it is what we call an extraneous solution. An extraneous solution doesn't actually work in the original
You
equation.
just know that by knowing that x plus 1 is near the bonds without doing all that other crap.
What now?
Well, you already know that there's no positive 1 in the solution above, so it would have to be -1. X equals -1.
What do you mean? What solution above?
Well, if you look at the x minus 1, and the denominators of both on each side of the equal sign,
Uh-huh.
well, there's no x plus 1, so it would have to be x equals -1. Because there's no x equals plus 1. I guess that doesn't work. Never mind.
You're right, it has to do with what's in our denominator.
Right, so the x equals plus 1 won't work. I mean, you already know that.
But this is what we got from x plus 1.
Right, which is our answer, x equals -1.
But
Do you understand what I'm trying to say?
no, because
Without having to do all the
you're saying there's no x plus 1 in the original one.
There's not.
Right, but x plus 1 is how we got the solution that does work.
Right. Never mind.
So you're right, it has to do with the denominator.
Right.
And the reason it doesn't work is because it makes the denominator 0.
Well, and x equals -1.
Doesn't make the denominator 0.
They make the denominators negative.
That's fine, though. We're allowed to divide by negative
Right,
numbers.
which is
We're
what
not
I'm
allowed
saying,
to
that
divide by
tells you
0.
That the x equals 1 won't work.
Correct.
Right. That's
I'm
what
not sure how you would have gotten the x equals -1 without solving the equation, though.
Well, no, you have to, but instead of going through and doing the checks, what I'm saying is, you already know before you go to do the checks.
Exactly. Good. We find restricted values at the very beginning. And then we don't have to check. That's exactly what we're doing. Good.
Okay. I'm sorry, I just.
So restricted values are values which make the LCM equal to 0. And we can find those from the beginning and know what x can't be then solve our equation, and then we can throw out any extraneous solutions by comparing them to our restricted values. So let's do one all together.
Now, is it possible that you can never have an x equals a -1 and an x, they have to be opposite, right? They would always have to be, are they always opposite?
No.
So you could have an x equals -1 and an x equals -1.
Yeah, or you can have an x equals -1 and x equals -25.
Right, so you.
I mean, you just get whatever solutions the
Right.
equation gives you.
That's what I was trying
Yeah.
to say.
So let's write it all out. So solving rational equations. And we'll do an example as we go through the steps. So let's do like that. Yeah, we'll do that one. X over x plus 4. That's a little small, huh? I'm anticipating running out of room. X plus 4 minus 4 over x minus 4 equals x squared plus 16 over x squared minus 16. So the first thing we're going to do, as you guys said, we have to figure out what the LCM is, right? And so just like when we were adding and subtracting fractions, to figure out what the LCM is, we're going to need to factor all our denominators. So we're going to start by factoring our denominators. So we need some parentheses. We have x over x plus 4. X plus 4 doesn't factor. And then minus 4 over x minus 4. And x minus 4 doesn't factor. And then x squared plus 16. And then x squared minus 16 factors into x plus 4 times x minus 4. So far, so good? Whoops. So the second thing we're going to do is find the LCM. Of the denominators. So my LCM in this case, well, remember we did this the other day when we were adding and subtracting. We said, okay, the first one has a factor of x plus 4. And then the second one has a factor of x minus 4. And then for that third denominator, I'd need an x plus 4 and x minus 4, but I already have both. So x plus 4 times x minus 4 contains all of the factors in my denominators. Notice we are not getting common denominators. We're not making the denominators the same. We're just figuring out what the least common multiple of the denominators is. The next step is to find what we call restricted values. By solving You're going to take your LCM and set it not equal to 0. We're doing not equal because we're finding the values that x cannot be. Right? X cannot be anything that makes a denominator equal to 0. So in this case, x cannot be -4 or 4. Right? Because if I did x plus 4 times x minus 4 is not equal to 0, we solve that the same way we solve an equation, just the symbol is different. And we get x is not equal to -4, and x is not equal to 4. So far, so good?
That confuses me a little.
Okay, what's confusing about it?
So, with our restricted value, we just told ourselves that our LCM, neither of our LCMs are okay.
No, we told ourselves that no x value that makes our LCM 0 is okay. Your LCM is x plus 4 times x minus 4. That the value of that changes depending on what the value of x is. We're just saying x can't be anything that makes it 0. X equals 4 is not your LCM.
Right.
It's not a factor in your LCM. Right? X minus 4 isn't the same as x equals 4. Like, x equals 5. Then your LCM is 5 plus 4 times 5 minus 4, which is 9 times 1, which is 9. That's okay. See what I mean?
Yes.
So,
Oh, okay. I'm with you now.
so what we're attempting to do when we solve the equation is find the values of x which make the equation true. When we clear fractions and we cancel all those denominators, our equation forgets that it used to have fractions in it, which can lead to solutions that might make the fractions not defined. So what we're doing is we're finding the values of x that would make that happen. So if x were -4, plugging it into one or more of those denominators would give us 0. And that's not okay because that's not defined. And so we're just saying that when we solve this equation, we have to throw out any values that are going to make the denominators 0, which in this case are -4 and 4. What are you shaking your head at? You just told me this very same thing.
I'm lost.
But you're the one who told me
I get
back
it on
here
that, but I
that,
don't-
that x can't be 1.
Right.
Right, so also x can't be 4, and x can't be -4.
Right.
Right. So now we can start solving.
Oh, so you're just checking to make sure that.
I am finding the values x cannot be first. And now I will find the values that x can be and throw out any of those that it cannot be. So when we solve an equation, we find all the possible solutions to the equation. It just turns out that sometimes some of those possible solutions don't actually work. And finding them ahead of time prevents us from having to plug them in later and do a bunch of calculating to see that they don't work. So next we are going to clear fractions. Which is done by multiplying both sides by the LCM. And remember, it's over 1. So I'm going to try very hard to fit this in here. So we are multiplying every term by x plus 4 times x minus 4 over 1. Sarah, could you swing that door shut for me? Plus 4, x minus 4, x squared plus 16. So we multiplied all 3 terms by our LCM over 1, just like we did back when we were solving equations with numerical fractions. So these look a bit bigger, but we're doing that same thing. So taking our LCM over 1 times each term. Remember, terms are separated by addition, subtraction, or equal signs. So in this case, we have 1, 2, 3 terms. Even if one of those wasn't a fraction, we would still multiply our LCM by it. So we have 1, 2, 3 terms, because those are separated by addition, subtraction, or the equal sign. So now we're going to go through and simplify. Well, my x plus 4 will cancel here. My x minus 4 will cancel here. And then both factors will cancel here. At this point, when you look across the bottom, the only thing there should be is 1s. Everything else should cancel out. And so we are left with x times x minus 4 minus 4 times x plus 4 equals x squared plus 16. All I did there was rewrite it. Notice, like, I didn't try to distribute anything there because I don't want to make a sign error by trying to distribute when I can't really see what's going on. So we just rewrote everything, and then we'll simplify and solve. So the next step is to solve the resulting equation. At this point, your equation is going to either be linear or quadratic. So to solve an equation, we always simplify each side first. So we're going to distribute and combine like terms on the left first. So we get x squared minus 4x minus 4x minus 16 equals x squared plus 16. Minus 8x minus 16. At first glance, this looks like it's quadratic because it's got that x squared in there. But notice that if I start trying to get a 0 on one side, when I subtract x squared from both sides, I get 0, right? So x squared minus x squared gets rid of the x squared on the left. X squared minus x squared gets rid of the x squared on the right. And so we really end up with a linear equation. So how should I solve that?
Add 16.
Yep, we'll add 16 to both sides. We get negative 8x equals 32. And then divide both sides by negative 8. And we get x equals negative 4. So you always want to ask yourself if it's linear or quadratic, because remember, if it's quadratic, you'll get 0 on one side and factor the other. If it's linear, we're just isolating x. And then the last step is to compare your solutions. To your restricted values. To eliminate extraneous solutions. So in this case, is x equals negative 4 a valid solution?
No.
It is not, right? And so since it's the only possible solution, that means that this equation has no solution. In our previous example, one of our solutions was extraneous, but the other one was just fine. So that was the only solution. If the only possible solution or solutions are extraneous, that just means there's no solution at all. So in the last example, we got 2 solutions and one was extraneous, but the other one worked just fine. So we had a solution here. If all of the possible solutions are extraneous, it means there's no solution at all. So it's possible to have all of your solutions not work. It's possible to have all of your solutions work. It's possible to have one work and one not work. It just depends on what you end up with.
So if it's the same thing as the restricted value, it's just no solution?
Well, if one of your solutions is the same as a restricted value, then that is not a solution. It doesn't mean that there's no solution, right? Like back here, we had a solution. The solution was x equals negative 1, even though the other one didn't work. So the equation can still have a solution. It just doesn't happen to be this one. In this case, we only had one possible solution, and it was a restricted value, and that's why we end up with what?
How do you know you only have one?
Because when we solved the equation, we only got one. We got x equals negative 4 is the only solution to the equation. So when we go through the process of solving, we're finding all of the possible solutions. So here we found 2 possible solutions, negative 1 and 1, and we threw one of them out, so the other one worked. Here we only found one possible solution. And it just depends on what type of equation you end up with, how many solutions you'll get. Right, when we had a quadratic, we factored, and so that resulted in 2 solutions. Here we just had a linear equation, so it only gave us one solution.
So you kind of almost already know that before you do the solution, right?
No.
Sure. 4 goes into 16, 4, so you're always going to have a 4 as part of your solution.
No.
No? Okay. Don't mind me. I see something different.
Wait, why do we need the restricted values?
Because they tell us what values x cannot be.
Okay.
So when we got to the end and we got x equals negative 4, our restricted values is what told us, like, no, that doesn't work. I need to throw it out.
So either positive 4 or negative 4, it doesn't work.
Correct. There are an infinite number of numbers that I could have gotten for x, which I don't know until I solve the equation. Yes?
How do you get the restricted values? Is it just what's in the denominator?
So we set the LCM not equal to 0 and solve. So in this case, we did x plus 4 times x minus 4 is not equal to 0. And we solve that exactly the same as we would if it was an equation. So that means that x plus 4 cannot be 0 and x minus 4 cannot be 0. And then solve for x. Usually these are kind of simple enough that you can see it just by looking at the LCM, right? It's like the opposite of that 4 and negative 4.
So all your LCMs will always be residual values then?
Anything that makes my LCM 0 is a restricted value. The LCM itself is not
Right,
a
because
restricted
your
value.
X minus 4 and x plus 4 is 0, right?
Well,
Is
if
that
you
how
s-
you're figuring?
if you set those equal to 0, the solutions are negative 4 and 4.
Right.
So the LCM isn't a restricted value. The values of x which make the LCM 0.
Just having these were the restricted values.
So x plus 4 isn't the same as 4.
No,
So x plus 4 is not a restricted value.
right, but
4 is a restricted
4,
value.
and then x minus 4. Well, minus 4 and plus 4 is 0.
So 4 and negative 4 are restricted values because if I put them in for x, it will make my LCM 0. You guys ready to do another one? Did you guys all write down the steps? Because it's pretty handy to go back to them if you at any point get stumped. Okay, I'm not going to be able to draw them. So we all have the steps. If not, take a picture now. Change the page. Okay. Let's do another one. So we're going to solve. Let's do 2 minus.
The difference between, one last question, is the linear versus non-linear would be the degree, right?
Yes.
Okay.
Good. Over x plus 3 equals x squared minus 4 over x plus 3. Okay, so remember our first step is to factor our denominators. In this case, neither of our denominators factors. So I'm just going to put my parentheses in, and that step is done. What is...
Ever factor numerator?
Not when we're solving an equation, because it's just like when we're getting or when we are adding and subtracting fractions. Notice in this step, I had to like expand everything. So if we had factored in an earlier step, I just would have ended up unfactoring.
Okay.
What's my LCM?
X plus 3 and 1?
So just x plus 3. Restricted values. X cannot be equal to what? Negative 3. Good.
Why is it negative?
So if I have x plus 3 is not equal to 0, so I take my LCM and set it not equal to 0, and then solve, we would subtract 3 from both sides. 0 minus 3 is negative 3. So now we're ready to clear fractions. We have 1, 2, 3 terms, so we're multiplying each of those by x plus 3. So we have x plus 3 over 1 times 2. If you want to put that over 1, you can put it over 1. Minus x plus 3 over 1 times x minus 2 over x plus 3 equals x plus 3 over 1 times x squared minus 4 over x plus 3. And just like all the other problems we've done this week, it's really important that you're just patient and like you write out the steps and don't try to smush things in and like skip over things. Like it saves you time in the long run to just write each step out in its entirety so you don't lose anything. So now we're ready to cancel. This x plus 3 will cancel, and this x plus 3 will cancel. So I'm left with 2 times x plus 3 minus x minus 2 equals x squared minus 4. Remember to keep all those parentheses, because not having parentheses, that's what causes sign errors. In particular here, if I didn't have the parentheses around that x minus 2, then I wouldn't distribute that negative, which would cause a sign error. Yes?
So then, is it ever possible to, like you said, you're always going to have 1 on the bottom, so you're always, if you don't have 1 on the bottom, then you did something wrong, right?
Yeah, you probably used the wrong LCM. The whole purpose of the LCM is it's a multiple of all the denominators, which means it'll cancel all the denominators.
It should always be 1.
Yes.
No matter what.
Mm-hmm.
Okay.
So now we're ready to simplify the left side, so we'll distribute. And I can drop my parentheses on the right side because there's nothing to the left of that leftmost parenthesis that needs to be distributed in order for me to get rid of those parentheses. So I'm looking like right here to see if there's a number I have to distribute or a negative sign I have to distribute, and there isn't one, so that's why I can just drop those parentheses there. But it's definitely something you want to consciously think about before you just start dropping parentheses, is why it's okay for you to do it. So we'll combine like terms. We get x plus 8 equals x squared minus 4. What type of equation is this?
Quadratic.
Yeah, it's quadratic, which means I want to get a 0 on one side. So I'm going to subtract x from both sides and subtract 8 from both sides. I flip-flop the left and right as well because we all like the 0 on the right a lot better. Here, I'll do this first.
It's like the Eustratic equation.
So I had x squared minus 4. I subtracted x from both sides, which got me that minus x. And then negative 4 minus 8 is negative 12.
So how come you don't subtract the x with the x squared just because they're not like terms?
Yeah, they're not like terms. Good.
You can put the 0 on either side, right?
Yeah, I'm gonna move it. I just wanted everybody to see
It's
this
annoying.
first. So then I'm just gonna put the 0 on the right just because it looks a little bit nicer. So now we're gonna factor the left side. It factors into x minus 3 times, x plus 3 times x minus 4. In the interest of time, take my word for it.
So you already know
And And then we're going to set each factor equal to 0. We get x equals -3 and x equals 4. And then we'll compare to our restricted values, and we see that x cannot be -3. So that's not a valid solution. So our only solution is x equals 4. So tomorrow we have a full review day for our test. So we're going to take that opportunity to do a few more of these and also do the written homework for tonight. So tonight you guys are only going to do your online homework. That way you can check your answers. And then tomorrow in class we'll do the written homework. And that way we can make sure it's correct and you're doing it right before we go into the test on Monday.
So tonight's homework, online homework is this?
Is solving equations, yep. So if you have any corrections, because you don't have written homework tonight, that tonight would be a good time to